Welcome back to the Gruber Motor Company podcast. And we have a special guest today, kind of a fascinating story. Teague Egan from a company called EnergyX, which is involved in lithium mining. And those of you that are in the EV space are probably concerned about there being enough lithium mined and on this planet. So that's what we're going to talk about today. Teague, I was intrigued by the story, how you got involved in this, and maybe we could start there. How did you get acquainted with lithium, and what's going on with EnergyX? Can you hear me, Teague?
I think we're frozen.
We're frozen, yep. You gotta love technology, don't you?
He's not here.
We're going to try to get our special guest back online here. Again, Teague Egan from EnergyX. And EnergyX is a company that has discovered a way to mine lithium ion in a way that is exponentially more powerful than the traditional ways of doing it. And hopefully when we get Teague back on here, we'll have him tell us more about how that's going to, how that works.
I don't know. I'm going to go upstairs to see if you can hear me.
So lithium ion has been called the white petroleum because it has the potential to replace fossil fuels. The EV batteries, of course, at this point have an enormous amount of lithium in them. And one of the things that we'll talk about is where does lithium come from? What is it? And what makes it so potent and powerful to store energy? And I believe that we are rejoining. And Teague, you went away for a little while.
Sorry about that, Pete.
That's okay.
I'm in the hotel, and my Wi-Fi dropped as soon as we started.
Well, you know what? I did some dancing, and we kept the audience engaged. And so anyway, let's start from where we left off, which is tell us a bit about EnergyX and how you get involved in this lithium project.
Yeah, absolutely. Well, today is a very exciting day for a lot of us. Ford just announced a huge investment in several battery factories in Kentucky with SK Innovation, who makes batteries and cathodes. So that's really good news for us. What EnergyX focuses on is a little bit further upstream, the actual production of the raw materials that go into batteries. So specifically lithium and direct lithium extraction technology.
You know, there's a fascinating story that that I read about your trip to South America and the Lithium Triangle. Tell us a bit about that.
Yeah, so turns out the majority of the world's lithium comes from a place in South America actually known as the Lithium Triangle. And I had no idea about this Lithium Triangle the first time I went down there. I was actually traveling, backpacking across South America, just as a tourist, and I went to Bolivia, kind of off the beaten path a little bit, and Bolivia stakes claim to the world's largest salt flat. It's a salt flat called Salar de Uyuni, and it's 4,000 square miles, just of absolute pure flat whiteness. It's a remarkable sight to see. And I'm on this tour with one of my buddies, and we're taking all the pictures and doing the tourist thing. And our tour guide starts telling us about how this is actually the world's largest lithium reserve at this salt flat. And I, had no idea what he was talking about. So I asked him questions. I said, "What do you mean?" He goes, "Well, the salt or the lithium is actually found in the salt brine below. Like this used to be a salt lake, which is pretty obvious, but lithium happens to be a salt that is found in these highly concentrated salt brines, like 20-30% salt. So Bolivia and this salt flat makes up an area in South America that also includes northern Argentina and northern Chile, called the Lithium Triangle, and they have about 65-70% of the known world's lithium reserves.
Okay. Now there's some other places in the world that have salt deposits, like Salt Lake City, for example, the Salt Sea, the Dead Sea. Are these also candidates then for this type of mining?
They are actually. So there's different concentrations of different salts in different areas. Like it's not all the same everywhere. But the Great Salt Lake has decent concentrations of lithium. Other salts that are found in these salty waters, like salt lakes, are sodium, of course. That's sodium chloride is table salt. Potassium, which you can make fertilizer out of. There's a lot of big industrial companies that work at the Great Salt Lake, of course, that make potassium chloride. It's this fertilizer, like Intrepid Potash. Magnesium is another salt. U.S. Magnesium is based out of the Great Salt Lake area. But lithium is also found in the Great Salt Lake area, as well as the Salton Sea in California. But they're just not as high of concentrations as are found in the Lithium Triangle in South America.
Fascinating.
It's like you can think about it like the Middle East. You dig down, and there's just massive amounts of oil. Like there's just so much oil concentrated there. There is oil in a lot of other places around the world, including the United States, offshore, but it's just not the same concentration that you have in the Middle East. That's basically what the Lithium Triangle is.
So are there other sources of lithium besides going into brine ponds?
Yeah, there are. So there's really kind of three classifications of lithium. One is, of course, brine that we just talked about. The second, which is equally as popular right now, but I feel like brine is going to become by far the most popular. But the second is mining lithium from like ore, like hard rock.
Right.
You typically think about the way that copper is mined in these big open pits. It's found in a spodumene ore, and you have to leach it out of the ore in the same fashion as typical hard rock mining. The third is it's found in some clays, so kind of like in between hard rock and brine, but that's far less effective. Clay, there's a lot of like mud and different impediments to extracting lithium from clay.
Now, currently, there's lithium mining going on. What countries dominate that type of mining at this point?
So the two biggest producers of lithium right now, from the brine side, is Chile. That's where the two biggest lithium companies in the world operate, Albemarle and SQM. SQM is purely a brine company. Albemarle has brine in Chile, and they also have hard rock in Australia. Australia is one of the biggest lithium producers as well.
Okay. Now, during Battery Day, Drew Baglino and both he and, of course, Elon were up on stage talking about the potential of doing some of this mining in Las Vegas. What are your thoughts on that? Or in Nevada, I should say.
Yeah, in Nevada. So they announced some pretty remarkable claims during Battery Day. Basically, they said that they figured out a way and theirs is the clay that I mentioned earlier, that they can sprinkle a little bit of table salt onto the clay and the lithium comes out.
Okay.
That caught the whole lithium industry off guard. But one rule of thumb of mine is to never doubt Elon. He usually comes through with what he says.
So you don't want to underestimate the guy. Yeah.
Yeah, probably don't underestimate him. if you're gonna, yeah. But the patent that they had filed on that method came out earlier this year, I think in January.
Yeah.
And when you read the patent, it's not as simple as they made it seem on stage, which
sure
nothing Elon says ever is. Like, he makes it sound very simple, but he's solving a lot of hard problems. What they actually are working on is they take the clay and they put it into these huge ball milling machines, and they basically like mill away the clay and are left with a solution that has lithium in it, right?
Okay.
So they're basically turning the clay into a solution that has, again, a relatively low grade of lithium, much lower than is found in the Lithium Triangle. And then they have to further extract the lithium out of that solution.
Okay. Now, the company that you're with, EnergyX, you were mentioning that they have developed a unique method of extraction. Can you expound on that a bit?
Yeah, so we focus on just brine, just the liquid solution, like really salty water that lithium is found in. And the way that we approach, so our company, as I said at the very beginning of this, is focused on direct lithium extraction. So the way that lithium is currently produced out of these salt brines is they pump the lithium brine out from subsurface and they put it into these huge evaporation ponds that are like literally tens of square miles bigger than New York City, all these collections of ponds.
Wow.
And they let the sun naturally evaporate the water, the H2O, and then the salts precipitate and crash out to the bottom, and then they scoop out the salts, and then the brine moves to the next pond, and these salts come out one by one. And this is literally technology that was invented by the ancient pharaohs of Egypt, like 1,000-year-old technology. And there's just never been any sort of improvement because we've never needed that much lithium.
Right.
And all of a sudden, now we need millions of tons of lithium to power the electric vehicle revolution. So a lot of people, including myself, I'm not the only one, are working on an approach called direct lithium extraction. How do we not use natural evaporation to separate lithium, but rather use mechanical separation and technology to selectively separate or target the lithium out of this variety of other salts that's found in the salt water, the salt brine. Right. So the way that we're approaching this is using membrane filtration. You think about the membranes that can create fresh water out of like drinking water out of ocean water. You're separating all of those salts out of this liquid, right? So we take our proprietary membrane, and only lithium can pass through it, and all of the rest of the unwanted salts are rejected. So now we have this pure lithium solution stream that's coming through, and then we can just crystallize just the lithium out of it. So it's basically, they're called mixed matrix membranes that selectively target just the lithium salts out of this salt brine.
So from everything you just described, it sounds like there are two distinct advantages. One is going to be reduced cost. The other is speed of recovery.
Right. Yeah, exactly.
In a brine pond, I'm assuming we have to wait for the sun to do its thing and get rid of all the H2O, correct?
Correct. So it takes about 18 months on average to go
18 months, okay.
serious ponds. Yeah.
It's kind of like watching the Salt Lake Sea evaporate or the Dead Sea evaporate.
It's like watching paint dry.
Like paint dry, okay. So this
Longer.
so this mining process, I would imagine then that Tesla would be a customer of yours.
Yeah. So Tesla is a little further downstream, but we actually sell our technology to the lithium producer. So these are big industrial companies that actually make the lithium, and then they sell the lithium to the battery cell manufacturer, which is LG, Panasonic, Samsung, SK Innovation, and then those companies sell the batteries to the automobile manufacturer.
Gotcha. Okay. Any projections about what the current lithium needs are and what it will evolve into as this EV eruption continues?
So it is the craziest shortage. It's the biggest bottleneck that the EV manufacturers face right now. And, you wonder why, like, I assume that you follow Tesla, and I assume a lot of your audience follows Tesla. Like you wonder,
audience, yes.
Yeah, you wonder why the Cybertruck is delayed another year, right?
Right.
He has 1.25 million pre-orders. Like why does he keep delaying?
Well, we thought it was just it was Elon's style, as he freely admits he has a problem with punctuality. But you're suggesting that it may be due to a raw material shortage.
Yeah, you think that it's just his style? I mean, he has what's 1.2 million times 60, or how much? What's the?
Oh, you're going to make me do math now, Teague.
Yeah,
It's staggering. Let's put it that way. It's just
how much is the MSRP for the Cyber? What do they sell for? 60 or 50 or something?
Yeah, I think they're up there high. Yeah,
Let's
high,
just
depending
say
on what options you get.
Yeah, let's just say it's 50. That's $60 billion of revenue that he's waiting on. You think he just wants to wait longer?
So it's not punctuality.
I mean, it's all supply chain, right? It's all supply chain. If he could be producing, I mean, the Cybertruck was announced like what, 3 years ago now, I think, or something like that. Like it's all supply chain, and he needs the materials to build this new type of car. I mean, you wonder why nobody else is producing electric vehicles. Like everybody wants to, but they just don't have the battery materials. It takes 10,000 iPhones to make one electric vehicle.
Wow. That's a fascinating statistic.
So if you're going to make 1 million electric vehicles, that's 10 billion iPhones. That's more iPhones that have ever been manufactured in the history of smartphones.
Right.
So the lithium is a huge bottleneck for the electric vehicles. So that's why it's such an exciting place to be in. I mean, it's like trying to build a city where you have to chop down every tree with a hand axe.
Yeah.
You're only going to be able to build one house a day when you need to build 1,000 houses a day, right? You need a chainsaw so that you can cut down trees in 1 minute versus 1 hour. Right.
So the whole goal of this type of transportation is to get rid of fossil fuel, which is a non-renewable resource. What about lithium? What is the planet's supply, and what is the projection? Are we going to run out? Or you might want to address this as well. What about reclamation? What about recycling?
So the good thing about lithium is that it's rechargeable, right?
Right.
So I first of all, sustainability is obviously very important, right? I think that there are a lot of people that are asking the same question that you just asked, and the first thing that needs to be considered is as somebody in the lithium industry and pushing forward this energy transition, what are we comparing ourselves to, right? It's all relative. I like to look at it in two buckets. One is the process by which we extract it from the earth, right? And we can try to make that more efficient, but at the end of the day, there's a carbon footprint for taking anything out of the earth, whether you're taking out oil and gas and fossil fuels, or you're taking out battery materials to make batteries, right? The second bucket is what happens after it's extracted, right? And fossil fuels are burned once and then they're gone. Lithium and batteries you can use for, we're working on making the 1,000,000-mile battery right now, and that's something that can last 10, 15, 20 years. So I've done the calculations, and for every 1 ton of lithium that is utilized in an electric vehicle, that reduces or replaces almost 150,000 tons of CO2 emissions.
Amazing.
Per year.
Right.
And then you're saying, okay, well, what if you're obviously charging your car with some sort of electricity, right? And that could be a non-renewable source. It could come from, natural gas or something like that. But if you use a renewable source, that's an additional 35,000 tons of replaced CO2. So I like to look at the carbon footprint that using rechargeable batteries creates over a year and then the life of a car. But even after you get past that, a lot of smart people, like the founding CTO of Tesla, JB Straubel, are working on lithium recycling. I mean, you have like a physical, tangible metal battery that can be reused. Now, obviously, smelting the battery down and separating all these things, like, of course, there's a carbon footprint associated with that. But at the end of the day, lithium is reusable, right?
JB's company, Redwood Materials. I think the reclamation percentage on lithium ran fairly high. So what you're saying is that we can continue to reuse this or recycle these lithium batteries.
Yeah, and that's absolutely correct. I don't think that we're quite there yet. Like, first of all, some of these early Teslas are like just starting to see end of life. Like I have a Tesla from 2013, which was the second year of production of the Model S. I think they made like a few thousand Roadsters, and then they started making Model S's in 2012. I have a 2013 Model S, and mine still runs 240 miles. Like it started at 265 range, and now it's down to like 235 or 240, and so it's still running at almost, it's considered end of life when your battery goes from 100% to 80%.
Right.
So
I was talking to JB Strobel about now 5 or 6 months ago or so, and he has 2 Roadsters. By the way, they were around 2400 built, 2412 or something like that. Yeah. And of course, we service them here, so we're intimately familiar with those. But what we found fascinating is, and in talking to him, he said, Pete, the design life of the Tesla Roadster battery pack, 6,831 18650 lithium ion cells, was 10
Wait,
years.
how many? Sorry, how many?
6,831, yeah.
Yes,
And
exactly.
he
Oh,
said
yeah.
that was a 10-year design life. We're all amazed that they're now going on 13 years and most of them are still going strong. What we see is also Tesla Model S's now. Yours is out of warranty and it may eventually end up at our shop because we rebuild your battery.
Where's
So
your? Oh, you're in Phoenix. All right,
yeah.
perfect.
So instead of the $22,000 battery swap that you'll find at the Tesla Service Center out of warranty, which is staggering when you consider it's a $25,000 to $30,000 car, we're able
Yeah,
to do that for about $5,000 to $7,000 and actually put it back on the road.
perfect. You got my business, buddy.
Cool. So, but yeah, the design life at this point is not matching up to actual specs. And to this day, no one really knows because Roadsters have been out since 2008. And
Right.
unless there's an aberration like they let it get bricked, which in the Tesla Roadster world means if you don't charge it for a couple, 3 months, it's going to go dead on you and no longer accept the charge. Fortunately, none of the other later platform Teslas have this flaw, but the Roadster does. So unless
Interesting.
you brick it, which we're able to recover, that Roadster today, 13 years later, is still running fine. So I suspect that you're going to have some more life in your battery in that 2013 Model S.
Nice. That's what I like to hear.
So all right. So in the meantime, um, the recycling aspect. What do you think of Redwood Materials' effort to recycle lithium? And do you think that that kind of effort will help us keep the or raise the production of lithium?
Yeah, absolutely. Absolutely. I mean, what I was getting at before is it might not be this year, it might not be next year, but battery recycling will be a massive industry in the next 5, 10, 20 years. And that's what JB is thinking about. It's undeniable that battery recycling is going to be a huge industry. Um, so, I am not intimate with the economics behind it, much less the process behind it. But just the general concept of battery recycling is a powerful thing.
Yeah. We know JB just recently announced plans for a mega factory well beyond the scope of Redwood Materials. So I know he's thinking about what the future is going to be.
Yeah, I think so. He announced that he's going to get into cathode manufacturing, right?
Okay.
Yeah. He's basically gonna use the materials that he recycles and build cathodes, because cathodes are one of the areas that the U.S. in general is lacking.
Right.
So currently, most of the raw battery materials, like lithium and cobalt and copper and nickel, are shipped over to China and made into cathodes. And then cathodes are one of the elements of cells that then come back to the US. So there's like this long logistical shipping route that
Mhm.
the battery materials go through. That's another huge carbon footprint. So, JB is getting on building cathode manufacturing here in the States, which is going to be a really big part of the EV supply chain.
I see. So I saw in one of your other videos, you're a Tesla investor.
I am. That's how
You
I
want
bought
to
my
tell?
Tesla. That's how I bought my Tesla in 2013. I bought the stock before the car, and
Right,
then stock doubled in 2 months, and I was able to buy a car.
right, right. Yeah, I think I got in it when I bought my Tesla Roadster in 2013. I got in
Wow.
around $30 a share, and I was excited because it doubled and I cashed out. I thought that was exciting, and that was pre-split. So can you
Yeah.
imagine if I had saved the shares back then?
Yeah. So I got in at $40 a share. Or no, I got in at $45 a share, and it split five times, right?
Right? Yep.
Yeah. So my post split uh, price was $9 a share, yours would have been $6 a share.
Right. So, what do you think of all of these other EV manufacturers that are now coming online? You know, the Lucids and the Neos, and yeah, what do you think about how that's going to affect the demand for this raw material, lithium?
Yeah, I mean, it's huge. It's you know, I don't know if I would put Lucid and Neo in the same category. I think Neo is an established. I mean, they're new, obviously, but they're already manufacturing cars over in China. Like
Right.
they have their act together. Lucid, you know, Elon likes to talk about the fact that he's the first car company to make it since Ford, right?
Right.
And he talks a lot about how it's easy to make one prototype. It's hard to make 100,000 cars. Like the jury is out. We'll see if Lucid can do it. We'll see if Rivian can do it. They have a lot of funding, but it's really hard to execute. So from that standpoint, I think that, well, from the other standpoint, I think it's super exciting that everybody's going in that direction. I mean, I more so look at Ford and GM, Volkswagen, like all the companies that are already there.
Yeah.
It's just added benefit if companies like Lucid and Rivian can make it. You know, that's just more lithium that needs to be
Sure.
turned into batteries.
Well, you know, I see the same manufacturers that you do, and it seems to me that a new manufacturer, like a Lucid, for example, starting their production line, starting fresh, is going to have an easier time to be successful than a company that needs to pivot. Ford, GM, how do you take this unwielding labor pool, unionized labor pool, and convert them and retrain them? And how do you convert your assembly lines, which are geared toward ICE production, to suddenly do EVs? It just seems like a much more difficult path for them than it does for these companies that are heavily funded, like a Lucid, for example, to enter this market.
Yeah, that's a really good point. I think it even goes one layer deeper. I think that uh, one point you made is absolutely true. Retraining your staff and having to hire new people to address this different type of manufacturing is a really hard challenge. Um, Tesla, of course, bought, I think it was, what plant did they buy in Fremont? I think it was a GM plant, or
Oh, you're talking about the Fremont plant.
yeah,
Yeah, that
that
was
was a
I think that was Toyota or Nissan. I forget now.
yeah, I think you're right. But they converted an ICE plant into an electric vehicle plant. So we know that that's possible. You
Right.
know, Elon has said since it's much easier to build your own plant when you can just do it from, but he got that plant for pennies on the dollar, right?
He got it for
The,
pennies, and they had gutted it though too. There was
yeah,
a lot of scrap sailing that was going
got
on.
it. The third thing though that's really hard is that these companies have um, stockholders to appease, right? You
They
can't
have
just
to. Yeah.
completely shift your
Yeah.
business and stop making, you know, the million plus vehicles that you are projected to make on an annual basis. Um, so, you know, I was just up in Michigan at the battery show and went to the Ford facility, and you know, it's absolutely massive over
Hmm.
there. And you know, so that's a challenge, figuring out how to allocate your use of proceeds into, you know, this transition that's clearly happening. You don't want to get left behind, but you also can't have, you know, a terrible quarter and be way below projections and things like that, right?
Right. Fascinating subjects. So, what are your opinions regarding where this industry is going to go? Who's going to make it? Who isn't? That type of thing.
I mean, when any sort of transition like this happens, there's inevitably people that are gonna die and not make it, and inevitably people that are going to succeed. Like you could see these new startups like Rivian or Lucid succeed. You could see one of them not succeed. Like we've already seen some people not succeed. I think Lordstown Motors is an example. Like, what separated Lordstown from Lucid, right?
Right.
It wouldn't surprise me to see some of the big, at least one or two of the big guys, maybe not just in the US, but overseas. Like you have to think about Europe. They have extremely stringent regulations on the transition away from ICE cars to electric vehicles. I think by 2035 is what they said, no more sales of ICE cars. But I think that the one thing that we can all agree on is that the energy transition is happening and the EV revolution is happening. I mean, the writing is on the walls. I actually think that instead of car companies that you'll see fade away or rise new, the real focus should be on the oil and gas companies. Those companies that don't adapt and move into battery materials and renewable energy, and because for oil and gas companies, it's not about what's happening next year or in 2025. Like think about where these oil and gas companies are going to be in 2030 or 2035, right? If they don't start planning for this transition and they're stuck in their ways of producing oil and gas, that you're going to see like, it almost happened to GE, right? GE was at $500 billion market cap. They dropped down to 50 billion. They lost 90% of their market cap. You could see an Exxon or a Chevron or a BP or, some sort of big company that you thought would never go out of business, all of a sudden go by the wayside. I think that the oil and gas is more at risk than the big auto manufacturers.
What I find ironic is the people that have been in the fossil fuel business could transition into mining lithium. It's comparable to what they've been doing, which is extracting some form of material element out of the earth. Well, it just simply changes from a brown liquid to a white salt.
Super
simple. That might be one step for them. The other thing is to migrate into the new disruptive technologies. Lucid, I understand, is owned by some OPEC money, or at least being funded by that. That would be a smart move for them as well. Do you have a website that you can give our audience that they can go reference for your company, ExpressX?
Of course, it's EnergyX.com. Very, very simple, straightforward.
EnergyX.com. Sorry, I got that wrong just now.
All good.
All right. Well, Teague, I appreciate you joining us, and we may have some other things to talk about in the future. I'm fascinated by your concept of extending the average life of a human. So that might be another topic that we could dive into and talk about. It's not going to be Tesla related, but it certainly is a fascinating subject.
You did your research, Pete.
I have. I would like to thank our audience again for visiting our channel and our podcast. And my staff always needs me to read a note here. Don't forget to smash that like button and turn on the notification bell. And check us out on Instagram and TikTok and our website, Gruber Motor Company. So again, Teague, it's been a pleasure, and I want to thank you for joining us.
Thanks a lot, Pete. Have a good one.
Take care. We usually have bloopers at